negative 4, 7, and do what with it? Plug it in. You're right. So the 7 goes in for the y, and the negative 4 goes in for the x. So then as we do a little bit of work here, we get 7 equals, what's negative 2 times negative 4? Order of operations, yep, we get 8. Wow, look at this. 8 minus 1 is 7. That is true. 7 does equal 7. So the answer would be, yes, that point is on the line. The reasoning there would simply be because when I plugged it in, it created a true equation as opposed to a false equation, like 10 equals 7 or something along those lines. Does that make sense? Do you have any questions? Okay, so then number 4, or really number 2, let me get a little better window on this one. Something like that, I guess. Okay, so the first part said solve for y. So when you guys see the word solve for y, how do you interpret that? Like, what is it kind of telling us to do? Find y, get y by itself. That's what I'm going to do. I'm going to try to isolate or get the y by itself. Okay, so then we look at that equation, and clearly the y on the left side of the equation clearly is not by itself, right? What are the two things that are with the y? A 3 and a 6x, right? So you can choose to get rid of either the 3 or the 6x first. The order will affect things. Which do you think would be easier to get rid of, the 3 or the 6x? It is easier to get rid of, in my opinion as well, to get rid of the 6x. How do I get rid of the whole 6x? Subtract it over to the other side, right? Yeah. So the minus 6x on the left side, minus 6x on the right side. What happens on the left side when I've got positive 6x minus 6x? Just adds right out, right? It's to 0. That's kind of the whole reason for doing this. And then on the right side, 15 minus 6 is 9. Is that good? No. Why? The terms are not like or different. We go with that. The technical ways say they're just not like terms. So I cannot do that. That would be a mistake on my part. So I just got to leave it as 15 minus 6x. Clearly, though, the y is not by itself yet. There's a 3 right there. How is the 3 attached to the y now? And how do we get rid of multiplication? I divide. So I'm going to divide both sides, but I'm going to divide like this. I'm going to divide both sides by 3. I'll split that fraction out. You don't have to do it this way. You could have just left it as one big happy fraction. Not a problem. This would give me 15 over 3, which is 5, minus 2x. So if you had 15 minus 6x over 3 is equal to y, that's fine too. Okay. So again, look at what you have on your paper. I gave you guys a lot of time and space to work that one out. Compare what you have with what I have. And if you've got that, that's great. If you have this, this is also great. If you've got both, it's double great.
What if you had negative 2x plus without
also just as good. I don't have room to write that, but that would be triple great. Yeah, no problem. No problem. In fact, you know, when we think about what we'll be doing here soon with the slope-intercept form, that's where you're headed, right? So that's fine. That's totally fine. Okay, the last thing we're supposed to do here is graph this. So let me ask you all this question. It comes right out and says, hey, it's a linear equation. So the graph had better look like what? It better look like a line, right? Otherwise, it's not really a linear equation. How many points at a minimum do I have to define this line? 2. It's often good to have 3 or 4 up there just to make sure you didn't mess something up. But you need a minimum of 2 to make this graph be what it should be. So I am going to put x's in that column, y's in that column. This last column would be x comma y. It'll give me kind of the point in the ordered pair format that we're used to. And so let's see here. Where can I will just slide this in over here to the left. Any suggestions? What could I plug in for an x? 1, 0, both great ideas. So I'll go 1 and 0. Here's how we find our y's. I take the x's and I plug them in, just like we've been doing. So for the 1, it would be y equals 5 minus 2 times 1. You follow the order of operations here, you get 5 minus 2, which is 3. So my first point is going to be 1 comma 3. What do you think? And then the 0, also a nice one. Y equals 5 minus 2 times 0. Well, 2 times 0 is 0, and 5 minus 0? 5. Great choice. So my next point would be 0, comma 5. Let's do a negative number to get a third point just to make sure. Joe?
Actually.
No? Negative number?
-1.
-1, -3, -2. I mean, if you said -47, I'd be like, I don't think so. -1, 2, 3, something like that. Let's go for some symmetry here. Let's just say -1. So this would be y equals 5 minus 2 times -1. And that equals? 7, yes. Negative times negative is a positive, right? So it's 5 plus 2. All right, so my third point would be -1, comma 7. And unfortunately, that's off the graph, isn't it? But we'll make it work. So my first point was 1, comma 3. So 1, comma 3 would be right about there. And 0, 5 is right about there. And then -1, comma 7 would be, I don't know, something like that. And then we always want to connect these points with a line that follows the pattern as best you can. So that's what I've got. And then I need to finish this off with what feature? Little arrows, yes. So the line should have arrows. Why on earth would the line have arrows?
To show that.
That's right. That's an indication that it just goes on forever. It's infinitely long. Okay. Any questions there? This is essentially, in a nutshell, what we did on Monday. So, all right. Is there, I don't remember. We're going to find out. There is. There's an intro video for Monday.
Yay.
But today's only Wednesday, so you guys have a lot of time to get that accomplished. So this has been, I do want to say this. I would say you guys have performed wonderfully, and it's been really, really good. Obviously, Coy? Obviously, not everyone has a 100%. In fact, nobody has 100%. Nobody's perfect, right? But I would say the one flaw in our approach is we have not done well with intro videos at all.
Really?
Oh, no. You maybe have. I think you have.
I have 100% on all.
Yeah, they're. I would say this. I do want to make myself as clear as possible. These are intended to be intro videos. And so if you do them late, you miss the point, right? You kind of miss the point. This is intended to give you 5 minutes of momentum heading into class versus, I forgot to do that, better check that box. I can help you, we can do that. But it would be best for you if, certainly if you use them as what they're intended for, intro videos. Okay? So, yes ma'am, question?
Are our projects graded?
Yeah, they're in the grade book. They're done. Yep, check those out. Yeah.
Your project, I think I forgot it, but I never wrote the
Yeah. Okay, awesome. Great. Have a great weekend, you guys. See you later. Where did I get 5 minus 2?
No, like to figure out the function or something. How'd you get that?
On the one we just did?
Yeah.
Okay. Let's see here. So,
Ava, can you pass me my phone?
so were you okay with
Nothing.
Were you okay with part A?
Yeah.
So this was y equals.
Yeah. Where'd you get the 5?
So it was 15 minus 6x over 3.
Yeah, I got that one.
So if you wanted to, what you could do is you could split your numerator. You could split it up like this.
No, on the last one, the graphic one.
Okay, yeah. So let's see.
Like, where'd you get
You guys can go on ahead of
5
me.
minus 2x or something?
Yeah. So that's what where I was going for. So you can split the numerator. 15 over 3 minus 6x over 3. What's 15 divided by 3? There's your 5.
Oh.
And 6 divided by 3, of course, is 2. So 2x. So 5 minus 2x. Is that what you were going for?
Yeah.
Okay.